In this lesson, I'm gonna talk about momentum and impulse. So, momentum or linear momentum is simply the product of the mass and velocity of an object. So, the momentum of a body of mass m, which is moving with a velocity v, is mv, or m times v, where m is the mass in kilograms, v is the velocity in meters per second, and the unit of the momentum is in kilograms meters per second or newtons second. So in this example, it says find the magnitude of the momentum of a cricket ball of mass 400 grams moving at 18 meters per second. So usually the momentum is denoted by P, so P is equal to mv. So the mass here is equal to 400 grams. However, I have to convert from grams to kilograms, so I will divide by 1000 times the velocity, which is 18, and the answer is equal to 7.2 newtons second. Now, to find the impulse is equal to the change in momentum, which is the final momentum minus the initial momentum, or mv, which is the mass times the final speed, minus mu, which is the mass times the initial speed. The magnitude of the impulse can be found by multiplying the force times the time. So in this example, it says a body of mass 2 kilograms is initially at rest. So the speed when t or when time is 0 is equal to 0 meters per second. So a body of mass 2 kilograms is initially at rest on a smooth horizontal table. A horizontal force of magnitude 4.5 newtons acts on the body for 6 seconds. Find the magnitude of the impulse and the final speed of the body. So in part A, the magnitude of the impulse, so I, is equal to force times t, so it's equal to 4.5 newtons times 6, and the answer is equal to 27, and the unit is Newton seconds. In part B, I have to find the final speed of the body. So the impulse, as found in part A, is equal to 27. This impulse is equal to the change in momentum, which is m, the mass, 2 times v, the final speed, minus the mass times the initial speed, and here, since the body was initially at rest, so u is equal to 0. So 27 is equal to 2v, so v is equal to 27 over 2, and the answer is 13.5, and the unit is in meters per second.